I've been requested to do a video on confidence intervals. So I'm actually going to take the two from the test. If you hear the whining in the background, those are my dogs. They want to get in, but they're being a bit disruptive, so my apologies. So on the test that we had, number 10, it reads, construct the 90% confidence interval for each of the following scenarios. You wish to estimate the proportion of automobiles that are purchased over the internet. You took a random sample of 200 people and found that 38 purchased a car over the internet. So the formula that you would use is programmed into the calculator. It's also in the textbook, and you have access to that for the final as well. So if you think about the normal curve, and if you draw it like a bell, and you pin the 90% in the middle, that means you have 5% in each tail. To figure out the critical values for the 90% confidence interval, you're going to do the second key, the VARS key, INV norm, and then you're going to do 0.05. Because 90%'s in the middle, that leaves 10% for the two tails to share. So when you do INV norm, let me make sure I get the right values. So second VARS, INV norm, 0.05. My calculator is getting more and more modern, so I did the second, the VARS, the INV norm, and I did put the 0.05 in the area. Now mine can go left, it can go center, it can go right. Most of you guys just automatically have it reading off of the center, so off the left. And I'm just going to go ahead and type in what I get from there. So I travel on down to paste. I'm going to highlight paste, and I hit enter on that, and then I get negative 1.645. So when you look at the formula where it says z sub c times the square root of p hat q hat over n, that z sub c is the 1.645. The p hat comes from the 38 and the 200, the 38 out of 200, which is 0.19. So you're going to have that 1.645, you're going to have the square root, you're going to have the 0.19, and then q hat is its counterpart. 0.81 is the q hat. So you're going to have underneath the square root 0.19, 0.81 over 200. You're going to multiply that value, and then you add that value to the p hat, and you subtract that value from the p hat, and that will generate your confidence interval. But your calculator will do it for you. So you go to stats, and you go to tests, and you look for 1 prop z interval. It's actually letter A. So stats tests 1 prop z interval. You're going to hit enter on that. And all it's going to ask for is your x and your n and your confidence level. And then you scroll down to calculate, and you hit enter on that. And your lower value is the 0.14, and your upper value is the 0.23. You are 90% confident that the population proportion is in between those two values. Now, for letter B on this, let's read through it again. In a random sample of 17 bikers, the mean time spent riding a day is 2.813 hours, and the standard deviation was 1.205. Assume the hours spent are normally distributed. Now, the normally distributed thing is important. It allows you to do either a t-distribution or a z-distribution. Now, the way you determine if you're going to use the t-distribution or the z-distribution is what type of standard deviation do you have? Do you have a sample standard deviation, or do you have a population standard deviation? They have to outright say population standard deviation in order for it to be the z interval or the z distribution. This just says sample, or I'm sorry, it just says standard deviation. So assume it's the sample standard deviation. So you, in this case, would use INVT. So on my calculator, I'll go second vars, INVT. And again, the area will be 0.05 because we've split it in half. But the degrees of freedom are your sample size minus 1. There were 17 bikers, so our degrees of freedom will be 16. You go to the paste, you hit enter, and it's going to look like that. INVT 0.05 comma 16 is going to be equal to negative 1.745. So that's the T sub C that you'd multiply by the sample standard deviation over the square root of your sample size. Again, your calculator will handle this for you. So go to stats, go to tests, and go to, I gotta find it, T interval. Okay. If you were doing, and you knew the population standard deviation, you'd be doing Z interval. Difference between section 6.1 in your book and section 6.2 in your book. So what you're going to be looking at is this input screen, and you can either go from data or from stats. We're going to be typing in the stats. If you are doing data, you'd be coming off of a list like L1 or L2. I'll scroll over and show you. So I've highlighted data. It'll ask you which list to access, and then you just scroll down to calculate. So I'm going to go over to stats. My sample mean, which is the X bar, whoops, got to bring that back in. The sample mean, which is my X bar, is 2.813. The sample standard deviation is the 1.205. Our sample size is 17. So what we have looks like that. Go down to calculate, hit enter, and we've got this 2.3028 and the 3.3232. Hopefully that's helpful and it shows you how to do confidence intervals. Thank you very much.